So this is purely not pre-recorded. Let's solve question number 1. At the beginning of a trip, the tank of Chloe's car was filled with 12 gallons. 12 gallons of gas. So she had 12 gallons to start with. So we're having 12 gallons of gas as the initial amount of gas she had. So when she travels constantly at the highway 60 miles per hour, the car consumes 1 gallon of gas per 35 miles. So for 60 miles, if the car is consuming 1 for every 35 miles, we divide 60 by 35. We'll know how many gallons of gas it consumed. Per hour, since it's going 60 miles per hour. So how many gallons would it consume per hour? How will we do that? So 60 divided by 35, 12 over 7, that's 1.714. So it consumed 1.714 gallons when you're driving at 60 miles per hour. Alright, so if you travel 5 hours and 15 minutes on the highway with a constant speed of 60 miles per hour, so this is what she's consuming for every 1 hour she drives 60 miles. So if she traveled 5 hours and 15 minutes, so we're multiplying this by 5 hours. Okay, and if you have 15 minutes, that's 15 over 60. 15 over 60 will give you 1 over 4, so that's 0.25. So you have 5.25. We're going to multiply 1.714 times 5.25 so that we can know the amount of gas the car has consumed. So we're having 9. This 1.714 times 5.25 will give you 9 gallons. It's consumed 9 gallons, but there are initially 12 gallons in the tank, so we have 12 minus 9, which is 3 gallons. Let's move on to the next one. Alright, looking at question number 2 here. A rock climber is climbing up a 450 feet high cliff. Okay, and by 9:30 a.m. the climber reached 90 feet up the cliff, and by 11 a.m. he has reached 210 feet up the cliff. So we're seeing 90 at 9:30. So from 90 at 9:30, so we're having 11 a.m. by 210. So there's a difference. The difference between 9:30 and 11:00 is definitely 2 hours, 1 hour 30 minutes, and 1 hour 30 minutes. It's moved from 110, from 90 to 210 in 1 hour 30 minutes. So they say if he climbs with a constant speed, by what time will we reach the top of the cliff? So we're having 210. Since we're going to be using minutes, 210. 1 hour 30 minutes is 60 plus 30, that's 90 minutes. So we're doing 210 divided by 90, that's 21 divided by 9. That'll give you about 2.33 feet per minute. 2.33 feet per minute. So let's assume it's already at 210. We're trying to get to 450. So we're having 450 minus 210. The distance between that is 240. So we have 240 feet, and he's moving at 2.33 per minute. So multiply that 240, that's the distance, over time is the speed. So so the time is equal to the speed over the distance, times the distance. So we have so the from speed is equal to distance over time. That means time is equal to speed over distance, distance over speed rather, distance over speed. So we're just gonna do 240 divided by 2.33. 240 divided by 2.33, and I think that will be our answer. So the answer will be minutes, since it's feet per minute, so the answer will be in feet per minute too. It will be in minutes. So here we're having 103 minutes. We're having 103 minutes. Now 103 minutes, add that to 11 o'clock. If you add 103 minutes to 11 o'clock, you'll be having remove 60 from it first, and you'll be having 43 minutes left. If you remove 60, that's 12 o'clock. So it's 12:43, about 12:30 or 12:43. Scrap all of that. So we have a rock 450. We have a rock climber going 450 feet high. By 9:30 he was already at 90 feet. He was 90 feet at 9:30, and he's at 210 feet by 11 o'clock. So we're just looking at how we can subtract this. If you subtract 210 from 90, you're gonna get 120. And if you subtract 11 from 980, you're gonna have 1 hour 30 minutes. That's about 90 minutes. So you divide 120 by 90 to look at the speed. So there you have 1.33. You have 1.33 feet per minute. Okay, so he's going to complete the remaining journey at the same speed. So that's from 210 down to 450. If you subtract 210 from 450, you're going to be having 240. And now let's write that. So we have to do 240. Remember that speed is equal to distance over time. This is actually the speed, 50 feet per minute. So if you rearrange this, you have t will be equal to distance over speed. Okay, so let's do that. 240 divided by, that's the distance, divided by speed, 1.33. So when you do that, 240 divided by 1.33, you'll be having 180. So you're having 180 minutes. Okay, since it's feet per minute, it goes up. Feet cancel, goes up. 180 minutes. So if you're having 180 minutes, you're going to add 180 minutes to 11 o'clock. 180 minutes, about 3 hours. So when you add 3 hours to 11 o'clock, you'll definitely land at 2 o'clock. So that's our answer, number 2B. Let's look at number 3. In 2005, a house was purchased for 280,000, and in 2013 it was sold at 334,000. Assuming that the value of the house increased at a constant annual rate, what would be the price of the house in the year 2018? So we have between 2005 and 2013. That's about 8 years. So in 8 years' time, the house moved from 280,000 to 334. So looking at the rate, we just simply subtract it. 334,000 minus 280,000. So that's 54,000 divided by 8. So we have 6,750. So yeah, it's 4,000 here. So that will be 6,750. That's what that's the increment. These are the rate. So $650, $6,750 per year. Okay, per year, that's the increase. So now saying that I don't want the value of the house increasing at a constant annual rate, that which is that. What will be the price of the house in the year 2018? So between 2013 and 2018, it will still be increasing by this. So simply multiply. What's the difference between 2013 and 2018? That's 5 years. So we're just going to multiply 5 times this 6,750, multiply it by that, and then add it to what this price here, because this is the new price that you're going to be adding at this rate to get to the next amount. So that's 5 times 6,750. That'll give us 33,750. Add that to 33400. So you have 334,000. That'll be 367,750. So look at that, 367,750. That's C. Let's go to the next one. Question number 4. Say to join East Lake Country Club, one must pay D dollars for a one-time membership fee and pay W dollars for a monthly fee. If the first month is free for the club, what is the total amount? Y. X month after a person joins the club in terms of D, W, and X. Now, just looking at this question, you know that this is what we call partial variation. Okay, partial variation. Now, normally partial variation follows the rule y equal to mx plus c, because actually what they mean is that y is partly constant, that is c, and partly varies as x. Partly varying as x, this is m here, is the constant of proportionality. What is making it to constantly vary? Okay, so y is either constant or it varies as x. So that is for joint partial variation. Now let's see how we can apply that here. To join East Lake Country, one must pay D dollars for one-time membership fee. That is the constant amount, which is D here. That's D. Then also, I'll pay W dollars for a monthly fee. So there's a monthly fee there, which he pays W. So X is the month. X is the amount, the month, because it's going to multiply the monthly fee by X, and then you will know the total amount. After paying the fee for registration or something like that, that's the membership fee or registration, you will now be multiplying your monthly fee by the amount of a month. That's X the person joined. So Y equal to WX plus D. That is the translation of this. So how else can we write this WX plus D? Let's see which of them would conform to this. So let's expand this. We have WX minus 1 plus D. That doesn't even look like it. But if you have this, Y equal to WX minus W plus D, that doesn't also fly. But they also told you that the first month is free, and we did not put that into consideration here. So if the first month is free for the club, that means you are going to subtract the first month. Now, which are you going to subtract from? Now, knowing that X here is the number of months, so whatever month that you want to pick, let's say you want to pick 2 months, you know the first one is free. So if you're picking 2 months, that's the first month, and any other month you will X minus 1. So multiplying that, X minus 1 plus D, you're having Y equal to this, so X minus 1. So this is the answer here, the B. Okay, w x minus 1 plus d, because the first month is free, and that's your answer. Let's go to question number 5. From 1990 to 2000, the population of city A rose from 12,000 to 28,000. The population of the city B rose from 18,000 to 24,000. If the population of the two cities increased at a constant rate, in year to year was the population of both cities the same? From 1990 to 2000, that's about 10 years. The population of city rose from 12,000 to 28,000. So you're simply going to subtract 28,000 and 12,000 from 28,000. You'll be having 16,000 there. So the population of city A rose from 12,000 to 16,000. That means in 10 years time there was an increase of 16,000 persons in 10 years time. Now they also say city B rose from 18,000 to 24,000. That's an increase of 6,000 persons in the same time. So you have 6,000 and still in 10 years time. So if the population of two cities increased at a constant rate, in what year was the population of both cities the same? So if they are going to increase, if the population increased at a constant rate, in what year was the population of both cities the same? Oh god, man. So what we're gonna do, 6,000 divided by 16,000 divided by 10, that'll just give you 1,600. And you say 6,000 divided by 10, that'll just give you 600. So that's a 600 persons per year. That's what's being added. 600 persons per year, and that's why in 10 years you got 6,000, and in 10 years you got 16,000. So say the population of two cities increased at a constant rate, which is this rate, which are the rates here. In what year was the population of both cities the same? So if you look at this started as this one here started as 12,000. So it started at 12,000 but slowly crept to 28,000, and this one started from 18,000 and slowly crept to 24,000. So let's say we're looking for a year where both of them are the same. So we're gonna divide let's use this least one here, 18,000. In the first year you're getting 18,600, but the other one, 12,000, will be having 18,600. So we're just gonna the first thing we can do, the fastest way to get this is by just multiplying this by 5. Let's just go halfway into it. 1,600 times 5, and we'll get that. 1,600 by 5, you're gonna get 8,000. Add 8,000 to 12,000, we'll be having 20,000. That's just in the first year, 5 years. So we're looking at a particular period where both of them will be the same. If you multiply that 5 by 6,000, you'll be having 3,000. And if you do that, add that to 18,000, you won't get 20,000, rather you get 21,000. But so you know that half of it wouldn't work. So it's definitely from 6 years and above, because half doesn't work. So you try the 6 times 1,600, you have 9,600. You multiply 6 by this, you get 9,600. Multiply 6 by this, and then add them to their respective numbers. So if you add the first one, 9,600 plus 12,000 will give you 21,600. You do 600 times 6, and it gave you 3,600. Add that to 18,000. If you add that to 18,000, you'll be having 21,600. So it's on the 6th year that both met, that they were exactly the same population on the 6th year. Remember, somehow it's a try and error thing. It's not really like a particular calculation that you could easily use. Of course, yes, there's an equation. Let's make that equation and see how we can do that in a mathematical pattern and not really a trial by error pattern. Since it is the same year, we're going to use x to represent the year. So for the first one, multiply 1600 times x plus the original amount, 12,000, is equal to $600, which is $600 times x. So we have 600 there times x plus 18,000. We're looking for when these two of them will be the same. That's why we equated them. So when would they be the same? So let's do this. 1600, this is 1600x, this is 600x. Move it to the other side. You have 1000x because you subtracted. You have 1000x equal to 18,000. Move 12,000 to the other side. You'll be having 18,000 plus minus 12,000 rather. 18,000 minus 12,000 give you 6,000. So if you want to do this, x is equal to 6,000 over 1,000, and that'll give you 6. So x equal to 6 years. In 6 years time, that's when both of them will have the same. So let's move to the next question. So here, question number 6 says an empty 1,200 gallon in order to solve this question, we need to visualize this. See, this is tank is being filled at 6 gallons per minute, and it is rising to a certain level x. Now, for this other gallon to be at the same level, we're looking at the entire thing, 1,200 minus this distance, minus this distance is the x. So everything here, the point from here to there, this point here, for it to drain from here to here is 1,200 minus x. So it's draining 1,200 minus x, while this one is clamping x. So we're going to multiply it. We're going to say this this is 6 gallons per minute, and it's trying to cover x. So if you want to use the time that it's using to do that, since we're looking for the time actually, okay, since this is 6 gallons per minute and this is x, I want to get minutes per minute here. So we're looking at multiplying it, but let's just try to get x first. Whatever we do to this side is what we're going to do to the next side. So we have x times 6 as 6x is equal to 1,200 minus x times 9. Well, that's what we're looking for. We're looking for that level actually first. 1,200 times 9. And you do that, you'll be having, let's solve over here. We'll be having 6x is equal to 1,200 times 9 is 1,200 times 9 is 10800. 10800 minus 9x. So you'll be having minus, if you move this to the other side, you have 6x plus 9x. So 6x plus 9x is equal to 10800. So 6x plus 9x will give you 15x. 15x equal to 10800, and if you divide that, you're going to be having x equal to 720. So a distance when it's 720. So if you look at that, 720 divided by 6, and whenever 1200 minus 720, that's 1200 minus 720 is 480. So here will actually be, this is 1000. So 480 is going to come out of here. If you look at the time, that 480 is going to come out of here, and when this one is going to be 7200. That's what it is. So we have this is actually correct, but there's a swap of this. It's actually correct, but there's a swap, because the draining actually here isn't here. Rather, this is where the draining is. It's actually correct, but this is where 480 is, and this is where 720 is. You see, 1200 minus 720 will still give you 480 down here. If you divide, because it's draining by 720, if you divide 720, remove 720, divide 720 by 9, you're gonna get 80. And if you divide 480, which is the rise here, by 9, you're also going to get 80. So you see, it rose by it dropped by 720 to get to the 480 gallons mark, while it increased by 480 to get to the 480 gallons mark. So